All right, guys, welcome to Law of Science Part 2, which is going to be interesting to say the least. Let's see what it is. It's called the ambiguous case. That's not a good sign when you start a video saying it's going to be ambiguous. Ambiguous basically means not real clear. So this is when you do law of signs using either SSA or ASA. And I'm going to give you the best way on that. Sorry, joking. The best way on how to do this for you. Really watch. Anytime you have one of these two cases, side angle or angle side angle, you have to worry about how many cases there could be. Sometimes there's going to be no solution at all. Sometimes there's going to be just one solution, and sometimes there's going to be two. But again, the only time you have to worry about it, and to be honest, the only time we're going to worry about it is with side angle, or even worse, angle side. Just saying. All right, first one says solve the triangle, and it's basically giving us the same thing we got yesterday. So what I'm going to do is, notice I'm okay to use law of signs because I know angle A and I know side A. Remember, they're opposites of each other. So I'm going to say, let's see, sine of 45, it's a terrible 45 over 7 on a square root of 2 equals sine of angle B over 7. Now, work it the same way, except there's one difference in doing this and what we did yesterday, and that is this. I'm going to cross multiply this way, punching that in right now, divided by the 7 on the square root of 2, and that's going to give me what sine B equals. Not what sine is, but sine B. Sorry, not what B is, but sine B. So I have to go second sine of that answer to figure out what big B is. And when I do that, I'm punching that in right now. And it's telling me B is 30 degrees. I'm going to put 30 degrees right here. Now, here's what you got to do when you're looking at this. And first of all, I forgot to mention this. I'm getting B equals 30 degrees. I'm going to skip right there. Sorry about that. B is 30. Now, I forgot to say this when we first started, but look what they gave me in this problem. They gave me a side, and an angle. So it was SSA to begin with, or ASS, depending on how you look at it. So it gave me 30 degrees. Now, here's what you got to do with this angle. Look at the 30, look at the 45. Subtract both of those from 180 to get your third angle there. So if I do 180 minus 45 minus 30, I'm getting 105. Which is perfect. Now I know angle C, and what the thing about that is that's the only angle I can get, and I'll show you what I'm talking about in just a second when I get to the two solution case. And then I need to find little c, side C. So I'm going to do the same thing I started with. I'm going sine 45 again over 7 on the square root of 2 equals sine of 105, which I just found, over little c. Cross multiply, divide by sine 45, and I'm getting 13.5 for little c. Okay, so there's my three answers right there. Now, that was a one solution case because I know that I already knew the first two angles were 30 and 45, and so there was no way I could get any other angle except for 105 on that third angle. And I will show you what I'm talking about. That doesn't make a whole lot of sense right now, but watch these next two slides. Okay, it says solve this one. And what they gave me here is I have big A, little a. And if I drew this triangle, it'd be side, angle again. Okay, so I'm still thinking about, okay, it could be no solution, could be one, could be two. So let's go through here. There's no choice how to start. I've got to do sine 43.1 degrees over little a, which is 186.2, over sine big B over 248.6. So there's like no choice there which way I go here. So what I'm going to do first is I'm going to multiply this way. Did that. Divide by 186.2. And when I do that, here's what I'm getting. I'm getting sine B is 0.91225. That's what my calculator showed me. To figure out big B, I'm going to actually do second sine of that angle. And my calculator's telling me this. My calculator's telling me it's 65.8 degrees. Now, here's where it gets a little crazy. I still need to find big C and little c, but there could be one case, could be two cases, could be no cases. I know it's not the no cases. It's either going to be one or two. And I'll show you in the next slide when you can tell there's 0 cases, when it's going to be no solution. And I'll be your best friend, by the way. But here's what I'm going to do. If there is another B, the way what the other B would be 180 minus the first one. And I'll show you exactly why that's the case in class tomorrow. We're going to do 180 minus 65.8, and if I do that, I get 114.2. Now, think about 114.2. I already know angle A is 43.1. So if I did 180 minus 43.1 minus 114.2, that's going to give me 22.7, which is also possible. Now, and I'm going to do it over here too. So if I do 180 minus 43.1 minus 65.8, that's going to give me, I'm trying to figure it out here, 71.1 degrees. So that's why there's two cases. One case is going to be over here with that angle B. The other case is going to be over here with this angle B. Okay, so I still need to find little c. So to find little c, I got to do law of sines 2 more times. I just messed up my screen there. 2 more times. So I'm going to come down. I'm going to start the same way I did a minute ago. Sine of 43.1 degrees over 186.2 equals sine of 71.1, which is my c right there, over little c. Cross multiply, divide by sine 43.1. What am I going to get here? I'm punching it in, trying to punch it in anyway. And I'm getting 257.8 right there. Now I'm going to do the same thing on this one. Sine 43.1 degrees over 186.2 equals sine, except this time, sine of 22.7 degrees over little c. Sorry for my handwriting right there. Cross multiply there, divide by sine 43.1. I'm getting 105.2. So 2 cases, case 1, case 2. And again, the way I did that again is I found the first angle C, actually found the first angle B up here for the first angle B, subtracted it from 180 right there to see if it was even possible to have another angle that would work. And sure enough, there was. On the last one, the last slide we did, there was no way I could subtract that because it was already obtuse. There was no way another angle would work. Okay, I hope that makes some sense. That'll make a lot more sense in class tomorrow. I promise you we'll work through it. But this is a good video to go back and even watch after class to see this exact slide. Let me show you one more case, the best case. Okay, the best case, I'm going to go ahead and tell you this is going to be a no solution case. I'm going to show you why and how that works right here. First of all, look what they gave me, side, angle. Okay, so I know it's the ambiguous case, the case we don't like as much. No choice what to do first. I know my A's, so I have to go. First of all, let's do this. I need to find big B, big C, and little c. That's what I'm looking for. What I know are my A's. So I'm going to go sine of 42 degrees over 70 equals sine of big B over 122. All right. Work it the same way. Cross multiply here. Divide by 70. And bad things happen. What happens when I do that math is I get this. I get sine B equals 1.17. Now, I know, because I know, and you do too, you know sine and cosine can't be bigger than 1 or less than -1. All right, so that already I know there's no way that can be true. If you try to punch it in your calculator, like you do second sine, if you hit this inverse sine of 1.17, it's going to tell you error on your calculator, and it's going to say domain because there's no way it can be that big. Okay, sine cannot be that value. So what that means is this picture, even though they try to draw a triangle with those values, it's not a triangle. So we just put no triangle or no solution. No triangle exists with those numbers. There's no way. It's impossible. All right, so that's all there is to it. So the good news about the 2-case scenario is your calculator will tell you every time. So the hardest one's a 2-case, and we'll work on that tomorrow quite a bit. You will not have any trouble once you see it a couple of times, I promise you. Can't wait to see you then.